going to deal with what is the effect of glucagon, epinephrine and insulin on glycogen. So as we know, the liver is the one of the main places where glycogen is stored, and on the need the glycogen is converted to glucose, and also the glucose which we take with our meals is converted into glycogen. So let's start. What is the effect of glucagon, epinephrine and insulin? On glycogen. What is happening is the glycogen is stored in the liver. So we have the glycogen which is to be converted into glucose, and when not needed the glucose is converted into glycogen. So there has to be a set of enzymes which are participating in their conversion. For that you should understand, if an enzyme ends with a kinase, it means the enzyme which adds phosphate using ATP. If an enzyme ends with phosphorylase, that means it is adding phosphate without any ATP use. And if the enzymes ends with phosphatase, then it means it is removing the phosphate. Now the glycogen converts into glucose with the enzyme glycogen phosphorylase. That means a phosphate is being added without the use of ATP and glucose is formed. Now glucose is converted to glycogen with the enzyme glycogen synthase. So glucogen to glucose and glucose to glycogen. What is the role of insulin? So we start with insulin first and then we will go to glucagon and epinephrine. Now insulin, the receptors of insulin are formed or are present on the liver as well as the muscle. So when the insulin acts on them, what it is helping? It is helping straight away the glycogen synthase enzyme, by which it converts the glucose into glycogen, and it also activates another enzyme which is called protein phosphatase, one which is important in removing the phosphate. So it is activating the protein phosphate also, and protein phosphate indirectly activates the glycogen synthase enzyme and decreases the action of glycogen phosphorylase enzyme. So indirectly it is helping this enzyme and it is inhibiting glycogen phosphorylase. Now the epinephrine has two kinds of receptors, alpha receptor and beta receptor. The alpha receptors are specialized locally on the liver cells, and beta receptors are present on liver as well as on the muscles. So if you find alpha receptors of epinephrine, they will be present specifically to the liver, and the beta receptors will be present both liver and the muscles. So epinephrine, if it is working on alpha receptors, that is the liver, what exactly it is doing is, it is making the endoplasmic reticulum to release the calcium. Now this calcium has few important roles here. What is this calcium doing? This calcium can directly act on an enzyme which is called glycogen phosphorylase kinase. It is a phosphorylase as well as a kinase, glycogen phosphorylase kinase. So this calcium can straight away activate this enzyme, or this calcium can participate in forming calcium carbamylin complex, which is important for the contraction in the smooth muscles. And this calcium carbamylin complex also activates the glycogen phosphorylase kinase. Next, we need to know about is glucagon. So glucagon has its receptors on the liver. What it is doing is, it is converting the ATP into cyclic AMP with the help of enzyme adenyl cyclase. Also, epinephrine, which is present, which is working on its beta receptors, which is on liver and muscles, is also acting in the same way, that is converting the ATP into cyclic AMP using the enzyme adenyl cyclase. This adenyl cyclase enzyme activates the protein kinase A, and this protein kinase A also activates the glycogen phosphorylase kinase. This glycogen phosphorylase kinase, finally activated by any of the three mechanisms, activates the glycogen phosphorylase. This protein kinase, where it activates the glycogen phosphorylase kinase, it inhibits the glycogen synthase. That means protein kinase A inhibits the glycogen synthase. So this is the relation of glucagon, epinephrine and insulin, how they are acting on the glycogen to convert it into glucose, and how the glucose is again converted back to glycogen under the effect of insulin.